in the third video, we will look at how we will implement the what stuff we already know and learned from this first and second part in building a simulator. So the first step is to go to Microsoft and download your free Visual Studio. It's called Community 2017, and if you have a previous version, it will work. But anyways, go there and download it. Play with it. And this video is not how to use it or to teach you the Visual Studio, but rather it's concentrating on one aspect, which is building and using it in Build a Simulator. Now, what we want to do is build a class for the tank, and how it looks like when you grab it and drop it into your form. It will look at this. It's black, gray with small message in the top. The small message, it's an optional. We can have it or not. It's up to you. Then I maybe need a tag for the tank and digits to show me the level, and maybe I have a meter, and then I have a timer. So these are the design time parameter, the tag, the diameter, elevation, and the elevation of outlet, and then this is my runtime properties. At the runtime, I will always change the inlet flow and the outlet flow, and then always will come up with my level. After you build the class, we need to test it. So we will build a small form which will have our class here for the tank, and then we will simulate the inputs and the outputs by a scroll bar, which we can change the value of the inlet and outlet flow rates, and here we'll have the flow rate. And then the checkbox here, when we check it, it will freeze the simulator. We will not run it. So we can look at what my inlet flow, my outlet flow, and what's my level at that moment. Then I can change it later on. So that's what we're going to do in Visual Basic now. After downloading and installing the Visual Studio, we will start with our first program. Go into File, New Project. Now here is a suggestion that if you want to go with the C language or Java, C++, you can do it. We will go with the Visual Basic. Visual Basic is very standard, easy programming. The one thing we need to do in the beginning, we will go with Windows Forms. Our first program will be Windows Form. It's called suggested as Windows Up 6. Doesn't really matter. It gives us the first form. So we have Form 1. We have a toolbox. In the toolbox you have a lot of devices you can have. So you can have drag a label, drag a button, and you can add a timer. If you look at the label, you find on the right side here you have the properties of the label. Our main task now is to add to those items a new device, which is our tank. When we grab it, drop it here, you will grab and drop our tank. So the first thing is that we need to do is, of course I don't need those guys, but go into Program, add user control. Now the first thing is that here it's give me a user control 1. I can call it, let's say, tank underscore 001. Just remember that this is a name you're going to use all the way. So you can call it here V vertical, C cylinder, tank, whatever. Now it opens the graphic representation of this user control.
this, whatever you will see, that's what you're going to see here. Whatever you design, you will see it here. And that's what you're going to see when you run your program. The first thing I'm going to do is I'll make it a little bit darker. Now, remember that we wanted to add here a text, a message text. Go into a label. Okay. And the background, I would think it's better to be red, because this is a message where I have a problem, and I will call it label message. Now, what in this label is that there is something called text in the properties, which is what is shown here. I will call it now check your data. So the check your data is my message. If everything okay, I will change the visibility of this control to true to false. From true to false. That means it will disappear. If I have any problem, I can keep this one on by showing the visibility as true. Next, I will add a new label for the tag. Every instrument has a tag. I will call it label tag or tag labeled. Now I will add in the text here again, and instead of call it label 1, I will call it T underscore or dash 1 2 3 4 5 6 7. The reason I'm putting this to see how it looks like if it is 8 or 9 characters. Then I can change the size of my control accordingly. I need to have another label to show me the level. Of course, it's not mandatory, but it's up to you. Now I need this to be white, and I will put in the label here 0.00 again, just to see how it looks like. And I will call this thing is level label. Or next I will add timer. This timer is called timer 1 by default. I will change it to be run timer. And the default would be 1 second. Now normally the timers are not enabled. When you drag and drop them, they are not enabled. So if I enable it, it will be running now. So the timer is actually clicking now. Next thing is that you build it. Now I will go back to my form design. Remember that I opened the toolbox to grab any one of those user controls. Here one, we have now a new user control. It's called tank 001. So that is our tank. Remember, we are in the design time now, not runtime. If I click on the start, that's mean now I'm running my program. Here is my tank and my buttons, nothing associated, nothing is doing nothing here. So back to the design of my tank. I can change, of course, the border size, just make it a little bit to be 3D. Just everything you do, go back and you have to build your solution. At the bottom here, if you have something wrong, you have the message in here. Now the second recommended thing I ask you to do is to keep making copies of your program and keep track of what you have been doing, because sometimes it's harder to fix the problem you have than start all over again. So if you, let's say, have a code which is making a problem, you don't know how to go around it and solve it, then probably you may be able to start easier from the previous saved revisions. So now it shows up in the Explorer my new user control, and here all the component underneath this control. Right now I don't have anything in the properties. This is the default properties comes with it. Now I need to add all my properties, which will be shown here, like the tank diameter and so on. Now we have two things. One is a view code and one is a designer. This is a designer, which is a graphic. Now we go into the code. This is the code of the class, public class tank underscore 001. All your codes will be resides here, and it will be moving from one place to another. When you save this and export it to a different program, that's all the associated control codes will be. So assuming I am double click on the runtime timer, this is the sub routine or the codes which will be executed every time this timer ticks. So assuming now I want something just for testing, I have something called level label. Sorry, label. Oh, okay. So level table label. When you press the dot, it gives you all the properties or things you associated with this tag. So I need to change the text of it to the second of the computer clock, which you can get it from date time dot now dot second. So this code will give you the result of it is the second of the clock. Again, build, go into the form 1, it's exactly the same, nothing changed because this is a code behind. Run it. You can see now when you run the program, the tank level here, it's now showing the second of the clock. Now we need to add something useful. We need to go back again into our code. So if you go on the top, you can see tank 1, which is our user control here, and this is my runtime clock. I can just I put comment here. I put comment like add all codes that will be executed each tick of the timer. Now I need to add my first property. I will assume it is the diameter. So of the tank. This is my comment. So it starts by declaring a variable private t underscore diam x as single. Now I will start to get my property t underscore diam as single. Then get return t underscore diameter x. Set value Now we added one property, which is a diameter, tank diameter, to our first user control. If you go into your and you drag a new one, let's drag a new one and see what's happened here. Now our new property, which is the diameter, shows here. I can change it now to 12, whatever number I need. So now this is how you add one property. Just delete this guy. I don't need it. I don't need even this guy. So now I'll go back into my tank. This is the first property. We said it is a tank diameter. I need a different type of property, which is the read-only property. Again, it starts by defining your variable private again t underscore level x The difference here now is this is my read only property. If you look at the first property, you have get and set. In the read only, you have only get. And this thing will return the value of my variable. You can see now we have the level, which is something will be calculated during each time the timer clicks, and those are the variable which will be changed during design time or during runtime. Second, build my system. If I go into the tool box, drag my tank, look at the properties, you can see two properties shows up. One is a level and one is a diameter. Now you can see why I added the t underscore in the beginning of each of my properties, because now I can see them all will be grouped together here in the banner. Sorry, in this property window. back to your design, we need to add more properties, which is a level, the height of the tanks, and all those kind of stuff. So instead of going and add them, I will show you a complete one. Before we go there, this is our form. Now, how are we going to test our tank? To test our tank, we have two things. One is the flow rate in, and one is the flow rate out. During runtime, I need to be able to change the flow rate in and out. You can drag a text box. Now the text box, when you type in something in it, that is, can be the flow rate. The another way of doing it, an easier one, is to go to a vertical scroll bar. So this my bar, in the properties, I can see there is a minimum, which is 0, and a maximum. I can make the maximum is 1000. So if I click on this guy, it's open the code when this thing change. Now if you remember, I have here two things. I have text box, I have a label. This called label 1. I will get the value of this bar in this label 1. So scroll bar 1 dot value. This is my value, right? What I need, I will put the label 1 dot text equal this thing. Now let's run it. What I did is that I added scroll bar. When you change it, you invoke or you ask this small subroutine to be executed, which simply takes the value of your bar here, scroll bar, into this label. Later on, what I'm going to do is, instead of doing this, I will do this and also assign the inflow to the value of this guy. So each time my timer will click, it will read the value of my value here from the scroll bar and associated or connected to my inlet flow, and so on. So that's how I will test my unit here, my program. Now, before we leave this and go into a more complete thing, if you noticed what we have here, we have form 1 has some stuff in it, and then we have our user control. You can delete form 1 completely with all its associated stuff. So what's in now in this program is one thing, which is your user control. That's the only thing you have here, nothing else. So when I save this guy, I have only one thing, which is the user control. So now I program it, I test it, I'm happy with it, I can delete form 1, and I have my program, which is Windows App 6, has only one thing, which is my user control. So the next step is if you go into your this is the program which is we are running now. Go into the you will find only one thing here is your tank 1 designer resources and Visual Basic. Those are the files associated with your new user control. You can take them and export them or imported them into your any other new project, and immediately you will have your new user control. Okay, close the solution. I don't care really about it. Now I will show you a more complete program. It's exactly the same thing we did before. This time I call it v_c_tank, which stands for a vertical cylindrical tank. And here all my properties. You can see the first one is the tag, exactly the same thing. Then the inflow, which is a numeric single. Outflow, diameter, overall tank height. I don't use it, but just in case I'm going to use it. The overflow pipe height, the outlet pipe height, and the level, which is read only. And then this is your timer. When each time the timer runs, the thing executed. So each time I did one thing here. This is my checking if I have my data is okay. So if my overflow height is 0 or my diameter is below 0, because nothing will stop you from putting the diameter as -5 or -2 or 0, or my tank overflow pipe, the height of it is less than the outlet pipe, then your message is true. Your message is this guy. Otherwise it's false, so it will just disappear, and we will see that. Now this is what I need to do when I program, when I run my system. That's the first thing I did here. If the diameter equals 0, then go to 10. Why? Because in the equation you divide by 10. By the diameter. So if the diameter is 0 and you try to divide by 0, you have an error. There is another ways to deal with errors, but to me I think it's sufficient for now. The first thing is the delta level and temp, because this is something intermediate calculation, equal the flow rate in minus out divided by pi, which is the area, and this is the volume change in second. Then you divide it by the run timer intervals, because this we made it as a variable. Our timer time at every 1 second. You may decide to change this to 2 seconds. If we said it's hard coded, it's always will be seconds, then I'm fine. I don't need to do this. But because it's open to be changed by the user, I have to get the value of the timer and get it in the calculation. Then the level change is the old level plus the new change. Then you check what is your new level. Is it below 0? Because assuming you have, for some reason, the output flow is positive and then you don't have any input, last period you have 0 level, then now it's minus. The level change is minus. The problem here is your simulator is not based on this thing only. It's depend on the other stuff, the pumps, which is takes from this tank, and if the tank level goes to 0, the flow from the pump should be 0. So the next run you should not have any problem. If the level below 0, then it should be 0. If it is more than the overflow, then it will be limiting to the overflow. Then I made some kind of approximation to round the number, because all this thing can give you 5, 6 digits. I don't want it, I have only 2. So this is my class. If you notice here, all of these are your properties. This is the command which will run each time the time clicks. And here I added one thing, which is when you load your user control, what action you want to do. Maybe you want to do something. I added here is it will take the tag and change it. So if you go into Formula 1 design, I can drag my tank here. Now if you notice, there is no tag, and I can go into the properties. I can find all the properties are listed here. I can find the diameter is 0 and the tag is empty. So if I put 1, 2, 3, 4, 5, 6, it doesn't show. When this thing loads during runtime, it will pick this tag and put it in here. The check properties here, because I have problem. I have the diameter is equal 0, so I can put it, let's say 5. Still shows up because my outlet pipe height is 0 and overflow pipe is 0. So I put this one, let's say 14. Now it disappears. If I put this one 14, then it shows back again. This is your outlet pipe. You cannot have the outlet pipe and the overflow pipe at the same height or elevation. So if I put this one is 0.5, everything is fine. So now I don't need this. What I did here in this form to be able to test my system here and how good I am in if I missed something, I added, as we said, the scroll bar for inlet flow and scroll bar for outlet flow. Now the tricky part is your new timer called connector. This timer is associated with this form. It is not the timer of the individual user. You can argue I can have one timer for both. In this case, we just, for the purposes of designing it, we said no, we're going to have one for each. What is this connector? The connector is each half a second will read the value of this timer scroll bar and associated to or connected to the inlet flow and this outlet to this inlet flow. So let's see what's the stuff here. So this is the only stuff I'm connecting here, which is, we call it connector. That's why it takes the inflow of the tank one and associated with or make it equal the Q input value. The Q input is my this guy, I call it Q input. This guy, I call it Q output. So the scroll bar, the first one is called Q input or Q output. It's up to you. Now here it is my connector. If you build a bigger simulator, you have 4, 5, 6, 7 user controls. In this connector, which is runs every half an hour, half a second or 1 second, you exchange the data between those guys. The other thing I have here is this guy checkbox is called run simulator, which is, if it is checked, I will make all the timers of my user controls enabled, or I can make them false. There is nothing else here. Now if we run the program, as we said before, in the beginning the tank level is 0. This is my inlet. I can set it at any number. There is no change. The reason that this checkbox is not checked, so the timer inside my user control is not running. But if it is I click it, it's running and it's reading the value, and this guy maybe have 2 meter by 10 meter height and so on. So I can see now my level changes, and it's changing. And if I have some outflow, you can see now that the rate of change is slower. Now if I exceed the flow rate in the outlet than the inlet, you can see that this thing is going backward, like decreasing. The level is decreasing. I stopped in all the inlet flow. My outlet flow still 900 meter cube per hour. I can see here the level goes to 0 and stops there. Of course, if there is a pump here, the flow will be 0 as well. So again, if you have a user control, you design it, you design around it all the inputs and outputs. You can read input, outputs, or variable inside it, around it, till you satisfy with the simulator and it's cover most, if not all, of your scenarios. Then you can take whatever you did and move it on to the next level, to the next program. Now this thing is running right now. If you look at the behind, I just left it in, this is my program. So if I can go into my even, I can go into my code of my user, and I put something here which is break, so it will stop my program. So and each time now if I run the simulator, it's not running, right? If I run it, it stops and it comes where I break the code. Now I can see I have a problem. I wanted to diagnose it and see what's happening. So this is one step inside your user during the runtime. Now I can step in it, because the first thing was checking if the diameter is 0. If you leave the cursor on top of it, it will give you the value of this thing. But also if you move it a little bit, it will give you the value of the whole thing. It's false. Now if I here, it's 991 minus 646 divided by the diameter, which is 2, and then I can step over to the next line. I can see what's my delta for the level and so on. So you can step inside the program itself. Then you can continue. It just continue and comes back again here. So you clear it and you continue. That means my program now is running. I'm okay. So this is how you add a user control to your program representing a tank, and you test it. You can have the same thing for a pump, valve, and then you can use it later on in any bigger simulation.